Hi, Henk Akmans here, Supply Chain Dynamics Chapter 8, Clip 9, More Concurrency Between Phases. So the topic of the chapter is concurrency, and in particular the hesitation with managers to allow for more concurrency between phases in the development process, which is pretty scary because you lose a bit of control, but on the other hand it may win you some time. Well, let's see to what extent it is true. First thing that I need to check is to see, let's make this a bit less long, else the overwhelming effect of the production rate will outweigh any of the, will tell us a lot more about manufacturing than it will tell us about concurrent engineering. So I've now reduced the simulation length to 200 months. Let's run, this is the base case. Nothing particular there, and I'm here in the detailed design. So here you see detailed design capacity coming up, and here you see the completion rate. Suppose that we then shorten that. Let's do something drastic, make that very 0.3, very much a recurrent thing. Wait a minute, before I do that, I probably first open up some of the graphs further down that can compare between various stages, because default I have them closed. And let's now go back to the original chart up here. Okay, now I bring this back to 0.9. I can either use the slider bar or type in a number. I have to be careful with dots versus commas. Okay, and we run this one. Oh no, first I should run the base run, of course, else I can't compare. Sorry about that. So, the comparative graphs have their comparison to make here, and then we put this at 0.3, which is so very quickly, very early on after the basic engineering start with the detailed engineering. In basic designs you don't see any difference. In the detailed design now you see an earlier start here compared to the previous stage. As soon as things happen, we start moving about. Does that mean anything for the total result? Well, then we have to make some, we still have this one open, some changes here, because the scale automatically is adjusted and doesn't have to be more than, say, 10 man years. Oh, that's too much. Not enough, actually. What could it be? 20? Yeah, 20 man years per unit development, and in manufacturing we can make this less also. Let's make this something like 80. These scales are adjusted, and with these bar graph, because they become have a very high value during the simulation, they're not adjusted what they are in the end. Okay, so this is the first case that we have up here. What if we have so the detailed design phase is already pretty concurrent here. You could try and see what would happen if you would make it less concurrent. But let's look at tooling here. For a more comprehensive comparison, also with tables and percentages, I recommend that you have a look at the text, which has all these things completely here. Tooling, where's my tooling? This is tooling. So this was tooling with concurrency between basic and detailed design. Now we keep that in original position, but let's see if we have tooling at a very, no, we should look at manufacturing, of course, because manufacturing will change as a result of a lower completion rate of tooling. Okay, there we go. So tooling can start, manufacturing can start sooner now, and you see that it can start so soon that despite the fact that there are problems with quality, it can already overcome its peak production period here before the end of the simulation, which is good. So starting earlier in tooling seems to be a very interesting scenario here. Now what if we put all three of them at a fairly concurrent mode? What will be the overall result then on manufacturing? And thereby on the total cost of the program. So everything starts sooner. There are drawbacks, of course, to sooner because there's more rework, but in terms of output it definitely works. But yes, we have had spent more development hours and more manufacturing hours, although we sold more planes in the meantime. The tables in the text provide some more detailed analysis of this, but if you look at these things, then you could almost think that it was actually not such a bad idea at all. Let's see what this does. We sell more planes, definitely. In terms of cost, we have lower cost per man year, so lower cost per unit. Of course, we have higher costs in development because there's more rework, but we sell more planes. So the cost, the overhead can be distributed over more planes. In terms of manufacturing, it's almost the same, I would say. There's not a huge big difference. There are differences, of course, in because of the higher concurrency, because everything's finished sooner. Now, is there a trade-off? Well, this model has some limitations. Not all the downsides of earlier manufacturing are noted, of more concurrency are noted. But what you can see is if you restore all devices here and you run a new simulation, a sensitivity analysis, where you put all these three things. The concurrency between basic design is at 0.1, it varies between 0.9 and 0.1. The detailed design, the same thing, and tooling at the same thing also. I prepared this little scenario and we run this then. In terms of total man years per unit sold, so a combination of both development and manufacturing man years per unit sold. Then this is the sequential mode, so very high required completeness, very low concurrency. This is modest concurrency. Takes some time to complete on this, somewhat slow, so that's a lot better in terms of fewer man years per unit sold, because you sell more units. This one should even be better, so here we are at, this is 0.9, this is 0.7, 0.5, and here we've got 0.3. So very high concurrency. Still not such a bad idea at all. Slightly higher than the previous one. But if you make it really crazy that everybody starts at the same time, say at 10%, at least in this model, what you get is higher cost in the end. So this is what they call a concave function. So anywhere in the middle is probably fine. I should stress that I've made later on, Kim and Van Oxford and myself have made later models in which this drawback of all this rework that is wasted is more prominently visible. But at least here you also see a concave function. So you should use concurrency, but you can overdo it certainly.